Now welcome back. Now on display is a prism, a triangular prism, and we will use this triangular prism to discuss angles between lines in 3 dimensions, angles between lines in 3D. I expect you to be able to calculate the length of a line in 3D. I also expect you to be able to apply various methods of solving a triangle, such as cosine rule, sine rule, and Pythagoras theorem, so that when we begin to calculate the angles between 2 lines in 3 dimensions, then you will be comfortable. So have your calculator ready and your pen and exercise book so that we can begin. Now, before we begin, I would also would like that you be able to identify objects in your environment that are in the shape of a prism. We can have a look at some of them. Here we have the roof of a church. It is in the shape of a prism. Here we have part of the roof of a residential house. You can see it is part of a triangular prism. We also have a roof of a classroom in a school. And this is a tent. All these are in the shape of a triangular prisms. You can explore your environment and be able to identify more of such objects that are in the shape of a triangular prism, because we will be understanding our drawing using real life objects. That will make it better and clearer. For example, if you look at the base, it appears to be a parallelogram, but in reality it is not. That can only be understood when you have at the back of your mind a real life object in the shape of a prism, so that each time you make reference to that real life object. Now, for now, I would like you to draw this prism. Once again, the dimensions are that AB is 8 centimeters. The length of the prism is 8 centimeters, and the base D, the width of the base DA is 6 centimeters. Now DE is 4.24 centimeters, and that DE equals to EA, so that DEA is an isosceles triangle. So kindly draw it in your exercise book so that when we return, we'll be able to present the problem. Specifically, we will be looking at the calculation of angles between lines in a 3-dimensional object. Welcome back. Now, I hope you have drawn the prism in your exercise book. There is further information that I would like to give you. Point M is on AD, so that M is the midpoint. Remember also that DE equals to EA, such that the triangle AED is isosceles. DA is 6 centimeters. AB is 8 centimeters, and DE equals to 4.24 centimeters. Now, using that information, I would like you to try the following. Calculate the lengths of the lines EM, MF, and MB. Now, this will help to jog your memory on calculation of lengths of lines in 3 dimensions. That was just the concept we learned earlier. It is a prerequisite knowledge in this subtopic. That is, before you calculate the angles between 2 lines in a 3-dimensional object, you need to be well grounded in the concept of calculating lengths of lines in 3 dimensions. That is So I would like you to calculate the lengths of the lines EM, MF, and MB. Then we can proceed. Okay. Okay, here is the working. I hope you tried and we can discuss the correct solution. Now, EM is the line from E to point M, which is along AD. As we discussed earlier, it is important to identify the plane figure on which EM lies. Now, EM is lying on the triangle AED, which we can extract and draw separately. And here it is. And remember, we said that triangle AED or DEA is an isosceles triangle where DE equals to DA, and that DA is 6 centimeters and DE is 4.24. Now, M is the midpoint. That means DM will be 3, and we want to get EM because E to M is vertical, it's the altitude of the triangle, then the angle DME is right angle. So to get EM, we apply Pythagoras theorem as follows, that EM squared equals to DE squared subtract DM squared. We bring in the values, and so we have 4.24 squared minus 3 squared. That gives us 8.9776, and EM is therefore the square root of 8.9776, giving us EM as 2.996 centimeters. All right. Now we look at MF. Let us analyze it. MF is the line from M to point F. You can look at it keenly. As we said before, it is important for us to identify the plane figure on which MF lies. Now, MF lies on triangle MFE. So we need to extract triangle MFE and draw it separately. And if we draw it separately, triangle MFE will be a right angle triangle at E. Now, in this triangle, we want MF, EF is 8 and EM is 2.996. So here we have it. And once again, to get MF, we apply Pythagoras theorem as below. MF squared equals to ME squared plus EF squared. We bring in the values, 2.996 plus 8 squared equals to 72.976. So our MF is the square root of 72.976, which is 8.543 centimeters. Right. So far, so good. We can next look at MB. Now, MB is a line running on the base. MB is here. It is on the plane ABCD. And let us have the plane ABCD, which is the base. It is rectangular in shape. We extract it and then we draw it side, and you can see it clearly. Here is the plane ABCD. Now you can see MB. AD is 6 centimeters and then AB is 8. Now we want to get the length of MB. So we can bring in the dimensions. So MA is 3 centimeters, and then AB is 8. So to get MB, we use triangle MAB, which is right angle at A, because ABCD is a rectangle. So MB squared equals to AM squared plus AB squared, that is 3 squared plus 8 squared, which gives me 73. And so MB is square root of 73, and we end up having MB as 8.544 centimeters. Right. So I hope you've jogged your memory on how to calculate the lengths of lines in 3D. We will use this knowledge when it comes to calculation of angles between two lines in a three-dimensional object. Now, let us move a notch higher. We scale up, and we want to discuss how to calculate angles between two lines in a three-dimensional object. And so I would like to ask you to copy this problem or discussion down, which we will use to explain how to calculate the angle between two lines in a three-dimension. Calculate the angles between lines A, ED and AD, B, EF and MF, and finally MF and MB. So take that down, and we'll take on each one of them by way of explaining the concept of calculating the angle between two lines in a three-dimensional object. Now, I would like us to begin with the angle between line ED and AD. Are you able to identify the line ED? The line ED is this one here. What about the line AD? So the first step is to identify the two lines. Next is to identify where they meet. So where does line ED and AD intersect? The two lines ED and AD intersect at D. So next is to look at the plane figure on which the two lines lie. ED and AD are both on triangle EDA. So we will extract that triangle and draw it separately. And this is what we have. So here we are. So this is the triangle containing ED and AD, and the two lines intersect at D. Now, let us bring in the dimensions of this triangle. ED is 4.24, and then AD is 6 centimeters. I think we had also got the length of EM as 2.996. So, which angle are we expected to calculate? Or are you able to identify the angle between ED and AD? Okay. The angle is angle EDA, the angle EDA, which is angle EDA is the angle between ED and AD. Now, I would like you to draw this triangle in your exercise book. Put the dimensions AD as 6 and then ED as 4.24 and then EM as 2.996 and calculate the size of angle EDA. All right. Okay. Next, we are supposed to look at calculate the angle between EF and MF. Now, are you able to identify the line EF? EF is this line up here, the ridge of the pyramid, or the ridge of the prism. And then we also have MF is here. So we have line MF and EF. The next step is to identify the figure which contains both lines. The figure containing both lines, that is the figure which the plane figure which contains line MF and line EF. All right, look at the prism carefully and try to identify the plane figure in which MF and EF lie. Definitely it is triangle MFE. So MF and EF, they both lie on triangle MFE. So we will extract this triangle and draw it separately and then use it to calculate the angle between the two lines. Right? I have said we first of all need to identify both lines MF and EF. Then next we identify the plane figure in which MF and EF lie. It is triangle MFE. So that means we will extract triangle MFE and draw it separately. And when we do that, we get this. So this is the triangle MFE, which contains both MF and EF. Now, we are required to calculate the angle between MF and EF. Are you able to see that angle in this triangle? Yes. Which angle are we expected to calculate? We have this angle, we have this one also, we have this one. Which one is the angle between MF and EF? That angle is angle MFE. So we are expected to calculate angle MFE. Now, what type of a triangle is MFE? It is a right angle triangle at E, and we can bring in the dimensions. We know MF, we had calculated it earlier. MF it is 8.543. We also know EF as 8, and we know EM as 2.996. Now, once again, I will ask you to draw this triangle in your exercise book and then go ahead and calculate angle EFM, which is the required angle between MF and EF. Okay. Try to work it out, then later we will be able to discuss the correct solution. Now, next we look at the angle between MF and MB. So we have MB, and then we also have MF. You can see both lines. As before, we are supposed to identify the figure or the plane figure on which both MB and MF lie. Look at the prism carefully, study it carefully, and identify the plane figure in which MB and MF lie. certainly that plane figure is triangle MBF. So we need to extract triangle MBF and draw it separately. And if you do that, you expect to get that. So here is the triangle we're going to use to get the angle between MB and MF. And in this triangle, you can study it and identify the angle between MB and MF. Which angle is that? The angle between MB and MF, the angle we are expected to calculate. It is angle FMB. The angle between MF and MB is angle FMB. Bringing the dimensions, MB is actually 8.544 and MF is 8.543 and FB is 4.24. So draw this triangle in your exercise book and go ahead and calculate the required angle, that is angle FMB. Now, after you've tried the three problems, that is the angle between ED and AD, then the angle between EF and MF, and also the angle between MF and MB, we'll come back and together discuss the correct working to allow you check your work and see if you got the correct answers. Just take your time and you can pause the video and try the three problems before we discuss them. Now, I hope you're ready with your work so that we can discuss the correct solution to give you an opportunity to compare and see if you got the correct answer. Now, the angle between ED and AD, this is the triangle we are using, and the angle required is angle EDA. And so we focus on triangle EDA, which is an isosceles triangle because we are given that ED and EA are equal. Now M is the midpoint of DA, and so DM is 3 centimeters and DE is 4.24. Now the angle between ED and AD is this angle here, the angle marked theta. Now we look at triangle DME, which is right angle at M, and we apply the Cosine rule, and we have cosine theta is 3 over 4.24, and that gives us 0.7075, and so our theta will be the cosine inverse of 0.7075, and once again we have 44.97 as the angle between ED and AD. Okay, you can check that against your work, and if you got it, well done. If you didn't get it, you can follow the working through to the end to be able to see where you went wrong. Next, we have the angle between EF and MF. Again, this is the triangle which we are using because MF and EF are both on triangle MFE, which is here, is right angle triangle at E. And so we have it here, the dimensions of that triangle, EF is 8 and EM is 2.996. And also we know MF as 8.543. Now the angle between EF and MF is the angle marked alpha, that is angle EFM. This is right angle triangle. So once again, we use the Cosine rule and we use the sine ratio. So sine alpha is 2.996 over 8.543, which is 0.3507. Alpha is sine inverse of 0.3507, and we have 20.53 as the angle between EF and MF. Follow through, and if you got it right, once again, congratulations. But if you didn't get it right, you can follow through and identify the point where you went astray. Lastly, we look at the angle between MF and MB, and this is the setup. This is the triangle we are going to use, and we look at it. It is not a right angle triangle. It's a triangle with all the dimensions given, because we know MB as 8.544, we know MF as 8.543, and we know FB as 4.24. Now, to get the angle between MF and MB, which is the angle at M, that is angle FMB, marked theta, is the required angle. We use cosine rule, and here is the layout. Cosine theta is 8.543 squared plus 8.544 squared, subtract 4.24 squared, all over 2 times 8.543 times 8.544. If you work it out on your calculator, you get cos theta as 0.8767, and our theta is the cosine inverse of 0.8767, which is 28.75, as the angle between MF and MB. That is the angle marked theta. Alright, you can follow through your working and check. You can pause the video and go through it keenly, and basically that sums up the concept of calculating angles between two lines in a three-dimensional object. I hope you enjoyed. We will in our next lesson look at more problems to give you more opportunity to practice. You can also go out of your way and try similar problems with a view to enhancing your grip on the concept. For now, thank you so much.